Good day, I am Roger VP Adante from B12 and today I will talk about the spread spectrum. Spread spectrum is a technique used to transmitting radio or telecommunication signals. It is originally developed for military applications to provide a secure communication. It provides a secure communication by spreading the signals into a large frequency band. To enumerate, spread spectrum is important for encoding methods in communication. Another one is that it is an analog and digital signal, data, in an analog signal. And then it spreads the signal over a large bandwidth. And lastly, it prevents interceptions and jammings. Spread spectrum has two predominant techniques. One is the frequency hopping and the other one is the direct sequence. Later on, we will talk about how the frequency hopping and the direct sequence makes it harder to jam the signals or to intercept them. The advantages of the spread spectrum are number one, immunity to noise and multipath distortion. Next one is it can hide or encrypt signals. And lastly, multiple persons can share a higher bandwidth with little interference. Then, what are pseudo-numbers?
It is generated by a pseudorandom number generator or PRNG, also known as a deterministic random bit generator. It is an algorithm for generating a sequence of numbers whose properties approximate the properties of sequence of random numbers. A pseudorandom number is generated by a deterministic algorithm. It is not actually random, but if the algorithm is good, results pass reasonable test of randomness. It starts from an initial seed. It needs to know the algorithm and seed to predict the sequence. And lastly, a pseudo-random number is only received and decoded by the receiver.
And now, let us talk about the techniques in spread spectrum. The first technique is the frequency hopping. The basic or the most simple concept for frequency hopping is making a narrowband signal jump into another random narrowband but with a larger bandwidth. And to graphically represent it, it is represented as this.
This figure shows how a signal jumped from a narrow band to another narrow band, creating a hopping pattern. This is a figure of an FHSS transmitter. For transmission, binary data are fed into a modulator using some digital to analog encoding scheme, such as a frequency shift keying (FSK) or binary phase shift keying or BPSK. The resulting signal is centered on some base frequency. A pseudo-noise or pseudo-random number serves as an index into a table of frequencies. This is a spreading code. The frequency synthesizer generates a constant frequency tone. A bandpass filter is used to block the difference frequency and pass the sum frequency, yielding the final FHSS signal. On the other hand, this is an FHSS receiver. The spread spectrum signal is demodulated using the same sequence of PN-derived frequencies and then demodulated to produce the output data. At the receiver, the signal is defined will be received. This is multiplied by a replica of a spreading signal to yield a product signal. A bandpass filter is used to block the sum frequencies and pass the difference frequency, which is then demodulated to recover the binary data.
To make the frequency hopping more easier to understand or simpler, let us give an example. When you're watching your favorite TV show or when you're listening to your favorite radio channel, it is a traditional narrowband radio and TV communication. But it has three main problems. interference, jamming, or interception. In wireless communication, interference and jamming could slow down the transmission. And interception is a huge security problem.
Given this example, suppose that we use all of the 2.4 GHz band. We can say that this can be easily intercepted or hacked because the data only travels in one channel. In order to address this issue, there are several signal modulation methods or techniques are used. One of this is the FHSS. This is how FHSS works. It is divided into several data travel time. For the first data, it travels to T1 of the F2, and then it will hop to T2 F5, and then it will hop to T3 F3, and then to T4 F6, and next to T5 F1, and then the next one T6 F6, and to the last one T7 F4, and so on and so forth. From the name itself, FHSS, there are different hopping patterns of the frequency. FHSS sends one data frequency at a time and uses different frequencies over the time.
We should note that the hopping patterns are only known to the receivers and the senders. And different senders uses different hopping patterns at different times. Next, for the second method or technique in the spread spectrum is the direct spread or the direct sequence spread spectrum. It is the most common or the most popular in modulation and transmission methods in the wireless communication. It introduces rapid phase transition to the data to make it larger in bandwidth. In comparison, the frequency hopping uses hopping to spread the data, while the direct sequence combines data signals directly with a higher bit rate sequence. First, let's talk about the simple process of how direct sequence spread spectrum works.
The DSSS has a very simple and general process. At the transmitter, the original data goes to the spreading modulator. A pseudo-noise or PN signal is added and mixed in the spreading modulator. This has higher bitrate sequence, a series of ones and zeros. The spreading modulator then distributes the transmitted signal over a much higher bandwidth. At the transmitter, at the receiver, these transmitted signals are modulated with PN code, and the original data are stored. In this process, each bit is coded and the signals bit are distributed over a much wider frequency band.
And now, let's get deeper and talk about how PN code works on the original data bit by bit.
This is how it works. Suppose that we send a 2-bit data of 1 and 0. To encode our original signal, we add some noise, which are PN sequences or chips like the PN sequence. The PN code has a higher bit rate than the original data. The exclusive or truth table is used to calculate and encode and modulate the transmitted signal. 1 and 1 is 0, and then 1 and 1 is 0 again. We use this pattern for the 1 bit. For the 0 bit, 1 and 0 is 1, and so on. Now, we get a transmitted signal which is a combination of our original data and PN code. It can be observed that the PN code has a shorter radio pulse than the original data. The smaller this duration, the larger the bandwidth of the resulting DSSS signal is produced.
And now, to explain or to answer how spreading of the signals could resist better the interference, the jamming, and the interception.
The red area represents the narrow band, which is easily jammed or interfered. In a narrow band wireless communication, more power is required to overcome jamming and interference. After spreading, the signal takes a much larger bandwidth. It uses the same power but the power density is spread out, which results to a lower power and noise-like signals, making it harder to detect and interfere.
Overall, I can say that there are three advantages of direct sequence spread spectrum. Number one is that it uses more bandwidth. The next one is that it is encoded data. And lastly, low power density and noise-like signals are used, which makes it harder to jam and interfere.
Baby, I got what you need. Break it down, I blow them tricks. The way that they talk about me. You think them niggas know me?